So 7.3.1, more patterns. So example 1 says to consider the following data table. So we've got years since 2000. So 0 is going to correspond to the year 2000, and 1 will correspond to 2001, and so on up to 2006. And we have the price for a particular product over here in dollars. So in the year 2000 it cost $1, in the year 2001 its price was $3, and so on. Okay, so part A, we're asked to find what patterns do we see in this collected data. Okay, so at this point you should pause the video because I'd really like you to think about what those patterns are on your own before you come back and sneak a peek at what the answers are. So if you want to try to answer parts A, B, C, and D, and then unpause, push play again, and see if your answers match the answers that I got. So you can push pause. Alright, so some of the patterns that you should have noticed in this data, and this is one of the patterns that we've looked at a lot, is as we're looking at the input variable, these keep going up by 1. And if we look at the output variables, they kept going up by 2 each year. Okay, so we have, constant changes in, we call this X and Y, in X, and constant changes in Y. Or maybe you had said that, years keep increasing by 1, and price keeps increasing by $2. Okay. So then we were asked to fill in the box with the number that continues this pattern. So if we keep adding 2 to get from 11 to this next box, if we add 2, we would predict that in 2006 the price was $13. So then we're asked if these are linearly related data. Okay, so this is underscored and in bold because it's one of our definitions from the last unit. So linear related data is whenever we have constant changes in the input are associated with constant changes in the output. So the answer here is yes, because we did have constant changes in both variables. So then we're asked to write price as a function of years since 2000. Since it's linearly related data, we know really what we're being asked for is a linear function. So our goal here is to write an f of x equals some slope times x plus b. Well, from the last unit, we were used to looking at where our output started for an input of 0, so the price originally was $1, and it kept increasing $2 every year. So we need to multiply that by the number of years. Okay? And so once we've got a function, you should check that it actually works. So if we put an input of 0 here, we do get 1. When we put in 1 for x, we get 1 plus 2, which is 3. If we put in x equals 2, we get 1 plus 4, which is 5, and so on. So this function does describe the behavior or the relationships that we see in the data table. So now we're asked to plot each row of data as an ordered pair, and what type of graph do we get? Okay. So here we've got 0 and 0, our x-axis and our y-axis. So our first point we had was at 0, 1, and then the next point in our data table was a 1, 3, so over 1 and up 3. Then we had a 2, 5, 3, 7, and so on. And we can see that these points fall in a straight line. And because we said that we had linearly related data. So from here we can see to get from one point to the next, we're going to go up 2 into the right 1, up 2 into the right 1, and so on, which was our slope coefficient. Okay. But in this section, we're going to start looking at another pattern in data. So again, I'm going to ask you on this one, we now have years since 2000 and different set of numbers for the prices. prices are still increasing like they were before, but not with the same pattern. So again, you should push pause and see if you can come up with relationship in these two sets of data, and then come back and unpause and see if your answers match what I got. Okay, so you can go ahead and push pause and then try to do parts A, B, C, and D. All right, so one of the patterns we should have noticed was that these keep increasing by 1, just like they did before. But over here, to get from 1 to 2, it went up 1, and from 2 to 5, it went up 3, so not a constant change. From 5 to 10, it went up 5, and from 10 to 17, it went up 7, and from 17 to 26, it went up 9. So there's not a constant change. But there is a pattern to these changes. Okay. So if we think about the numbers 1, 3, 5, 7, 9, okay, these are all our odd numbers. These numbers are all just 2 digits apart. And so that means our next change number here, to get to the next number in the box, if we continue the same pattern, we would add 11 and get the number 37. Okay, so the patterns here that we see, again, if we want to call these X and Y, okay, X keeps increasing by 1. And now over here in the Y's, we didn't have a constant increase, but these changes all had a constant change. So in here we could say, Y keeps increasing. In this case, it was, by the next odd number. Or we could have noticed that there was a constant change in the changes. Okay, so again, we didn't have a constant change in Y, but as we looked at the changes in Y, those had a constant change. So are these linear related data? And the answer here would be no, as we don't have constant changes in both variables. We do in the X, but not the Y. And we've already filled in the box that would continue the pattern that we saw. So now if you plot each row of data as an ordered pair, so I'm just going to write these down here so that we have them. 1, 2, 2, 5, 3, 10, 4, 17. It's going to be enough to see what's going on. So again, if we have here's 0, 0, X, and Y, and so if we plot the point 0, 1, and then 1, 2, 2, 5, and now already we should be able to see that this is not linear, and then 3, 10, again, definitely not linear, and then 4, and 17. And we're starting to see kind of a curve to this data. Okay, so this is not linear. And actually later we're going to see that we're going to get something that is called a parabola.